let's let's practice graphing a couple of rational functions. My recommendation to follow this quote unquote template, given the function first, let's find the domain. So let me just write some keywords. So every time we need to deal with the domain, what do we need to look for? The denominator. Cannot be zero, right? We need to avoid zero in the denominator. Then we move to the VAs, vertical asymptotes. So what's so important of the vertical asymptotes? We have to remember that the polynomial, the rational function must be written in its lowest form. That's one thing that we must remember. For the horizontal asymptotes, well, it's the whole deal with the degrees and lead coefficient, right? Something that we have not done. How do we know if it's intersect? So what do? We need to solve, to answer the question, do we intersect? We need to solve the following. We need to solve the following equation. We need to take the function equal to the HA. Okay, we take the function equal to the HA. How do we find the y-intercept? Of course, we make x equals 0. How do we find the x-intercepts? In general, y equals 0, but since we're dealing with rational, we can just limit ourselves to make the numerator equals 0. Then we identify the intervals, and there's respective signs. The interval will be given, we are talking about the x-axis. Intervals in terms of the x-axis. How does my x-axis get quote unquote chopped based on the information that we have? So let's try one simple example. Let's see if I can keep my little template here. Example number 1. F of x equals 3x minus 6 over x plus 4. Okay. Let's see, what is the domain? The domain, we need to avoid zero in the denominator, so the domain is defined by all real numbers except -4. So the domain of real numbers except -4 VAs, for the vertical asymptote, we have to make sure the function is in its lowest form. Notice that even if I factor out the 3 here, that will be x minus 2, doesn't simplify, so that's fine. So the way it's written is in its lowest form. So the VA therefore is only one, x equals -4. Are we going to intersect the vertical asymptote? Never, ever, ever. We intersect the vertical asymptote. Now, how do I find the HA, the horizontal asymptote? Well, we need to look at the degrees. So the denominator is 1, the denominator is 1. Since we have the same degree, then we look at the lead coefficient. This is coefficient 1. 3 over 1 is 3. So we have an HA at y equals 3. 3 over 1, 3. Now, do we intersect? Yes or no? Maybe, we don't know. How do we figure it out? We need to take the function equals to the intercept, okay? The HA, the horizontal asymptote. So what is my function? The function will be 3x minus 6 over x plus 4, and we equal it to my asymptote, which is 3. So let's go ahead and solve this one. So we don't know if the function ever b equals to 3. That's what we're trying to figure out. So I put a question mark. How do I solve this? Of course, we always multiply by the LCD. In this case, my LCD is x plus 4. So we proceed to multiply by x plus 4 on the left, x plus 4 on the right, x plus 4, x plus 4, x plus 4 over x plus 4 is 1. Therefore, on the left-hand side, I have 3x minus 6. If that jump can ever be equal to what? 3 times x, 3x, 3 times 4, 12. Okay. If I were to subtract 3x, so I have all my x's on the left-hand side, 3x minus 3, that would be 0. So I end up with negative 6 equals 12, which of course, this is a fallacy, this is false. So that means that I can never make 3x minus 6 over x plus 4 equals to 3. So do we intersect? Absolutely not. So this is one case that we do not intersect the horizontal asymptote. Why? Because we could not solve the equation function equals asymptote. F of x equals HA. Always, how do I answer this question? Is f of x equals to the HA. In this case, we attempted to solve it and we found something, a fallacy, something stupid. Therefore, the HA is y equals 3, and no, we do not intersect that HA. So let me erase this. Now, how do I find the y-intercept? Well, we find f of 0. 0 times 3 times 0 is 0, negative 6. So that would be negative 6 over 0 plus 4 is 4. Negative 6 over 4 would be negative 3/2. So my y-intercept would be 0, negative 3/2. My x-intercepts, what do I do? Since we are dealing with a fraction, we force the numerator to be 0. So when I have 3x minus 6 equals 0, 3x equals, I add 6, that would be 6 divided by 3, x equals 2. So my x-intercept would be x equals 2. So 2, 0. Now we proceed to identify the intervals and the respective signs. What I'm going to do, I'm going to rewrite the function here. Let's see if I can do everything in one place. 3x minus 6 over x plus 4. So what do we know so far? Let's see if we can. What do we know? What do we know so far? Okay, let's see. We know that the domain is all real numbers except negative 4. So the function is not defined when x equals negative 4. Moreover, at x equals negative 4, that's my asymptote. X equals negative 4. So we already know what's the behavior of the asymptote. As I get closer to negative 4, the function will go up or down. We don't know. We have an HA, horizontal asymptote, as y equals 3. Let me start over again. I do apologize. Y equals 3 is my horizontal asymptote. So we have the vertical asymptote at x equals 4. X equals negative 4. It's not defined at x equals negative 4. And my horizontal asymptote at y equals 3. And we never intersect this guy. That means what do we know about the horizontal asymptote? At x goes very, very small, the function will be very, very close to y equals 3 from the bottom or y equals 3 from the top. We don't know yet. And we never intersect this guy. So we cannot cross y equals 3. That means that the graph will always be on top of y equals 3 or below y equals 3. As I get closer to negative 4, the graph will go to positive infinity or to negative infinity. Likewise, Now, we have y-intercept is -3/2. By the way, I always do this last, so it's somewhere here, negative, but I always do that last. And my x-intercept 2,0. So I must go through this point. That's my x-intercept. I must cross x-intercept. I know I must touch x equals 2. Either cross or bounce. We don't know. Okay, so let's see what we have. Now we have intervals of interest, so negative infinity. So what are my intervals? Let's see. My intervals are from negative infinity to -4, then from -4 to 2, this was 2, yeah, this is -4, this is 2. So from -4 to 2, and then from 2 to infinity. Notice what that I don't care about the y-intercept. We always look at the intervals in terms of x. What is the behavior of the function when we look at x? So my x-axis got quote unquote chopped from -infinity to -4. Something funny is happening here. From -4 to 2, something is happening here. And then from 2 to infinity, something happens. Now we need to choose any number in this sub-interval. So any number less than -4, I don't know, let me choose -6. So -6, let's choose any number. Please don't choose, if you're going to test this interval, don't choose -3, -2, -1. You need to choose -5, -6, -7, -1 million. But please left off -4. Going to choose -6, so let's see. 3 times -6, that would be -18. -6, the numerator will be negative. -6 plus 4, the denominator will be negative. Last time we checked, negative over negative will be positive. Yeah. Now, -4 to 2. I'm going to choose any number. I'm going to use 0. So you already know the 0, so the answer will be negative. Let's do it again. 3 times 0, 0, -6, that will be -6 over 0 plus 4 is positive. So negative over positive will be negative. Last but not least, any number bigger than 2. So let's go ahead and use 4. 3 times 4, 12 minus 6, that will be positive. 4 plus 4 is 8, positive over positive, positive. Okay, so now let's see if we can have a very rough graph based on the information we have. We know that between -infinity and -4, the function has to be positive. So I need to be above the x-axis. Okay. Now, as I approach -4, the function has to go to positive infinity or to negative infinity. Since I know the function has to be positive, of course, it's going to shoot to positive infinity. Notice that the graph cannot start here between 0 and 3. Why? Because even though here is also positive, but I need to go all the way to infinity. So if I start in this space here, I know that I have to cross the asymptote, horizontal asymptote, which I know that I cannot, right? We already discovered that we will never cross this one. So I have no choice but to be above the asymptote, and then I'm stuck in this space here. Notice that when x goes to -infinity, the function will attempt to get to 3. That's your horizontal asymptote. Perfect. Now, from -4 and 2, the function is negative. Okay, that means that I have to start from the negative world. Okay, and then that means that I need to start from the negative world because this is the asymptote, but I have an y-intercept, a -3/2, and I have the 2, so I need to reach to 2, passing through my y-intercept and coming from the negative world. So going from the negative world, my x-intercept, and I get here at 2. Now, from 2 to infinity, the function is positive. Okay, so I need to continue like this. And am I going to go above y equals 3? Never, but this is my asymptote. So we go here at 2.99999. And that's my graph. So the graph will look like very small here. It will be here, one piece, and the other piece comes like this. The other portion comes like this, and like that. Even worse. So you have a boomerang type of shape here, and the other shape here. That will be it. Okay. Going through my y-intercept, going through my x-intercept, not crossing or touching y equals 3, and not touching x equals negative 4. But this is not part of the domain. And that will be it. It looks ugly, but hopefully you got it. Okay, I would like to do another example. F of x equals x over x squared minus 16. It will be interesting once we do this one. It will be interesting to explore this one, x minus 4 over x squared minus 16. And if you're curious, you may attempt these two, x minus 2 over x squared minus 16, x minus 8 over x squared minus 16. Quite interesting how the graph will take different shapes just by modifying the numerator. Okay? Both in its basic form, x minus 2, x minus 8, x minus 4. As I said, we will work on this and this one. And then these two, I will leave it up to you to check them out. So let's start with f of x equals x over x squared minus 16. Once again, if I were to factor the denominator, that's x plus 4, x minus 4 over x, that's kind of a sloppy, but you get the idea. What is my domain? The domain will be given by all real numbers except plus or minus 4. All real numbers except plus or minus 4. If I factor the denominator, there is nothing to simplify, so I would experience two vertical asymptotes, one at x equals negative 4, and the other one at x equals 4. Do we have any horizontal asymptote? Actually, we do. The degree of the numerator is 1, the degree of the denominator is 2, therefore y equals 0 would be your horizontal asymptote. Do we intersect? We don't know. How do we find out? We need to solve an equation, which equation the function equals to the intercept. X over x squared minus 16 equals 0. Okay. So let's go ahead and find out. We multiply by the LCD. So of course, here multiply by x squared minus 16, x squared minus 16, x squared eliminate. So we have x equals 0. Yeah, we were able to solve it. Not only we will intersect, and I know that will intersect at x equals 0. Okay, so let me erase. So we know that the horizontal asymptote is y equals 0, and this guy we will intersect at x equals 0. What is my y-intercept? Of course, we plug in 0, 0, 0. So from this point forward, this portion here will be very redundant because of this that we already found out. However, I'm going to continue just like following the template, the pattern. But again, everything is redundant. We already know the answer. Just by notice that we intersect at 0, that means that the origin is part of the solution, so everything will be origin here. So how do I find the y-intercept? Well, you know it. But anyway, 0 over 0 minus 16, that will be 0. So the y-intercept is indeed 0, 0. Oh, the origin, okay. And how do I find the x-intercept? The origin. So we make the numerator equal 0, so x equals 0. In other words, the origin, as we knew it many times, is part of the graph. And now we are ready to identify the intervals. So let's see. F of x equals x over x plus 4 times x minus 4. That's my function. Now, what are my intervals? I have no clue. Let's find out. So this is what we have. We know that negative infinity to infinity. We know that 4 and negative 4 are not part of the domain. And this is where my asymptotes go by. So those are my two vertical asymptotes. My horizontal asymptote, I always forget, is y equals 0. So let me just put it an overlay line here so I remember that my axis is the asymptote. So y equals 0 is my asymptote, my horizontal asymptote. This is negative 4, 4, of course, negative 4 and 4. And my y-intercept is the origin 0. And this is where I'm going to intercept my asymptote, that's 0, 0, of course. Okay, so let's go ahead and look at the intervals. It will be from negative infinity to negative 4, negative 4 to 0, 0 to 4, 4 to infinity. We have a lot of them. So let's see what we have. We have from negative infinity to negative 4. Then we have from negative 4 to 0, 0 to 4, 4 to infinity. 1, 2, 3, 4. Perfect. Any number between negative infinity and negative 4, let's go ahead and use negative 10. Okay, so I'm going to use negative 10. Let me not do this. Okay, so just use any number smaller than negative 4, negative 10. So what do I have? What do I have? Let's see. Negative 10, of course, is negative. Negative 10 plus 4, that's negative. Negative 10 minus 4, that's negative. 3 negative, the answer will be, oh my God, the answer will be negative. Okay, so I have 3 negative in multiplication division, the answer will be negative. Okay, let's do the next one. Anyone between negative 4 and 0, let me choose negative 2, so the number will be negative 2. The denominator will be negative 2 plus 4, that's positive. Negative 2 minus 4, that's negative. Negative to negative, that will be positive. The other interval between 0 and 4, any number, let's just go ahead and use 2 as the number, as a test number. When x equals 2, of course, that's positive. And then I have 2 plus 4, that is positive. 2 minus 4, that is negative. So the whole thing will be negative, only one negative. Last but not least, a number bigger than 4, let's go ahead and use 10. Of course, 10 is positive. 10 plus 4, that's positive. 10 minus 4, that's positive. So the whole thing would be positive. Okay, let's see how we can interpret this. Always remember the definition or the behavior of asymptotes. Negative 4, I mean, so from negative infinity to negative 4, I am negative. So I have to be below the x-axis. And of course, I have this asymptote at x equals negative 4. So I have no choice. If I'm going to be negative, I have no choice but to grab the boomerang. Always remember boomerangs here. Now, from negative 4 to 0, the function is positive. Well, I cannot start from the negative world. I need to start from the positive world. But I need to get to 0. 0 is my x-intercept, so I must go through 0. Okay, let's stop there. Now from 0 to 4, the function is negative. Do I go back to the positive world? No, I need to intersect my asymptote and continue to the negative world. Remember, the asymptote has to push me down as positive or negative, so I must go to the negative world. Why? Because they told me it's supposed to be negative. And then from 4 to infinity, the function is positive. I cannot intersect my asymptote, my horizontal asymptote anymore. I did it only once at 0. So from 4 forward, I will not touch it. And then, of course, it's positive. So I need to start from the positive world, but then I cannot go below the asymptote. So that would be the other part of the quote unquote boomerang. So that's my function, folks. There you go. Pretty. Let's try one more example. F of x equals x minus 4 over x squared minus 16. So what is my domain? Well, we need to factor first. X minus 4 times x plus 4. Well, notice that we have to avoid two numbers, 4 and negative 4. Therefore, my domain is all real numbers except plus or minus 4. Domain all real numbers except plus or minus 4. Do we have any VAs? Well, we don't know. We need to rewrite or attempt to simplify the function, which in this case, it simplifies. It will be 1 over x plus 4. So yes, we'll have one VA at what? X equals negative 4. And we know that since we simplify, we exchange one VA for one discontinuity, point of discontinuity or hole. So this one will have a hole at x equals 4. So one VA, one hole at x equals 4. Do we have any horizontal asymptotes? Well, we don't know. Let's see. Degree 1, degree 2. The denominator is higher than the numerator. Therefore, we do have a VA at y equals 0. Do I intersect? I don't know. Let's find out. How do we know that? We need to take the function f of x. F of x equals to the HA. Now here we have two choices. You can take the original or the simplified one. I highly recommend you take the simplified version. So we have 1 over x plus 4 equals, how much is the VA? 0. So how do I solve this? I multiply by x plus 4, my LCD. So here, x plus 4 eliminates. So you get 1 equals 0, which is a fallacy, so it's false. So therefore, do we intersect? No. So what do we have so far? We know that the horizontal asymptote equals 0, and we do not intersect. Okay. What is my y-intercept? We make x equals 0, 0 minus 4. So f of 0 equals negative 4, 0 minus 16, negative 16. So it will be 1/4. So the y-intercept, 0.14. And the x-intercept, of course, we make the numerator equals 0. Once again, I highly recommend to use the simplified version. So here my numerator, of course, is 1. And can 1 be 0? Of course not. So no x-intercept. If you do not take the simplified version, you take the original one, we'll be solving the equation 4x minus 4 equals 0. Numerator equals 0, therefore x equals 4. So your candidate will be 4 will be your intercept. However, you know that 4 is not part of the domain, so you have to kill it. This is what I say, might as well work with the simplified version. And now we are ready to identify the intervals. So this is what we know so far. We know that we have we have a vertical asymptote at x equals -4. X equals -4. We know that x equals 4 is not part of the domain, so we'll experience a hole somewhere here when x equals 4. We know that y equals 0 is my horizontal asymptote, and I will never intersect the horizontal asymptote in this example. And I don't have any x-intercepts, no x-intercepts. So what do we know? How many is interval? -infinity to -4, -4 to 4, 4 to infinity. Okay, not that bad. So let's see, what are my intercepts? Where am I here? -infinity to -4, -4 to 4, and 4 to infinity. Any number less than -4, maybe -6. I'm going to use the simple version, the lowest version. Notice that 1 is always positive, obviously. 1 is positive, 1 is positive. So there's no question that, that's easy. What do I have? What do I have? Oh, when x equals -6, -6 plus 4, that would be negative. And negative to negative would be negative. Positive or negative, negative. In the number between -4 and 4, we can use 0. Well, if you don't want 0, you can use 2. So 1, of course, is positive. 2 plus 4 is positive. Positive, positive, positive. Bigger than 4, 8. So positive, so positive. Okay, so we are ready to graph this, hopefully. We know, what do we know? What do we know? I don't know anymore. That the function is negative between -infinity and -4. I cannot cross my asymptote, my horizontal asymptote. I cannot pass -4. Moreover, the function pushes me to be negative. So I have no choice but to draw my boomerang here. I'm stuck between these two asymptotes, horizontal asymptotes and the vertical asymptotes. Okay, from -4 to 4, the function is positive. And by the way, my y-intercept is 1/4. So I'm going to the positive world. I go through my y-intercept and I maintain positive. I cannot intersect my asymptotes. Now from 4 to infinity, the function is still positive. But then I'm going to do something that I'm going to erase it. So I continue being positive, but without being restricted by the horizontal asymptote. So it will be like this and continue being positive. Now there is a discontinuity at x equals 4. We just simply, the function is not defined when x equals 4. So you will see a hole here when x equals 4. And that would be it. So we traded the vertical asymptote for a hole at x equals 4. And that would be it. That is my graph. Okay, folks, I will stop the video here. As I told you, I would challenge you to attempt to graph these two functions, f of x equals x minus 2 over x squared minus 16, and then f of x equals x minus 8 over x squared minus 16. I will do them, but I will not explain them. So I will pause the video, I will work it out, and then I'll start the video again so we can compare notes. I'll do it for the first one. Then I'll stop the video, we'll pause the video, work on the second one, then I'll continue, I'll resume the video. Okay, I just don't want to make the video way too long. I think now it's more than an hour. So let me pause, I'll work on the first one, you work on it, we'll compare notes, Likewise for the second one. If not, you can just close the video at this point. Thank you. Let's recap very quickly. How do I graph x, the function x minus 2 over x squared minus 16? First of all, let me factor the denominator. X minus 4, x plus 4. Domain of real numbers x at 4. VA is -4, x equals -4, x equals 4. Do I have any horizontal asymptote? Yes, indeed. Y equals 0. Do I intersect? We just simply take the function equals 0. The function equals to the HA, which is 0. So x minus 2 equals 0, x equals 2. So yes, we will intersect the HA, the horizontal asymptote, at x equals 2. We will intersect at 2. How do I find the y-intercept? We force x to be 0. 0 minus 2, -2, 0 minus 16, -16, that's positive 1, 8. How do I find the x-intercept? We already knew it, but let's do it again. The numerator equals 0, x minus 2 equals 0, therefore x equals 2. Okay, so what are my subintervals? -infinity to -4. From -4 to 2, this is my x-intercept. From 2 to 4, and 4 to infinity. I just rewrote the function here, it's easier for me. So any number between -infinity and -4, I chose -6. -6 minus 2, that's negative. -6 plus 4, negative. -6 minus 4, negative. 3, negative, negative. When x equals 0, 0 minus 2, 0. 0 plus 4, positive. 0 minus 4, negative. 2, negative, positive. When x equals 3, between 2 and 4, I just chose 3. 3 minus 2 is positive. 3 plus 4, 7, positive. 3 minus 4, negative. 1, negative, negative. And from 4 to infinity, I chose 6. So everything will be positive, so positive. Hopefully you get the same trend. So let's see what we have. From -infinity to -4, the function is negative. I'm stuck between the two asymptotes, horizontal asymptote, vertical asymptote. Function is negative, so this is where the boomerang goes. From -4 to 2, the function is positive, so it has to come from this VA, from the positive world all the way, but I have to hit 2. And of course, I need to intersect my y-intercept, which is 1/8. I need to go through 1/8 here and to 2 in x. So intersection and then stop here for now. And then from 2 to 4, we continue negative, so we continue going down. So that's my graph in the middle. And then, of course, the last one is positive, horizontal asymptote, vertical asymptote. We have no choice but to graph it there. So that will be your graph. The last example, f of x equals x minus 8 over x squared minus 16. This is what I got. As always, factor the denominator. Actually, I didn't even erase. So up to here is the same, domain and the VA. Now the horizontal asymptote, y equals 0 still. Do we intersect? Yes, we do, but in this case, we intersect at x equals 8. Right, so the function equals to 0, numerator equals to 0, x equals 8. Not at 2, where we used to do it before, not at 0, now we intersect at 8. Y-intercept, 0 minus 8, 0 minus 16, -8 over -16, which is 1/2. Therefore, 0,1/2 is my x-intercept. My y-intercept. Let's go ahead and find the x-intercepts. Do we have any x-intercepts? Yes, we do. X equals 8, right? X-intercept, the numerator equals to 0. So therefore, x equals 8. Between here. Okay, so what are my subintervals? So from -infinity, no, what do we have? The vertical asymptote, x equals -4, x equals 4. I'm hitting the y-axis at 1/2, 0.5. Vertical asymptote, horizontal asymptote, y equals 0, and I'm going to intersect the asymptote at 8. Okay, so let's see what we have. That's what we know. Of course, -4 and 4 are not part of the domain. That's it, no more no other x-intercept, only one at 8. Okay, so negative infinity to negative 4 all the way to 4, 4 to 8, 8 to infinity. Those are my subintervals. Choose any number. I chose negative 6. So negative 6 minus 8, that's negative. Negative 6 plus 4, negative. Negative minus 4, negative. 3 negative is negative. I chose 0. 0 minus 8 is negative 4, negative 4, therefore positive, only two negative. For the next interval, from 4 to 8, I chose 6. 6 minus 8, negative. 6 plus 4, 6 minus 4, both positive, therefore negative. Last but not least, a number bigger than 6, I chose 9. Or 10 doesn't matter. Positive, positive, positive. So everything is positive, so therefore positive. Okay, so let's see how this function looks like. I forgot to graph it. Negative. Negative 4 to 4, the function is positive, so I come from here. Now, interestingly here, I need to go through my y-intercept. So now, the function is still positive. So I don't go to a negative world, I have to go to the positive world. So I go up here somehow. This asymptote will let me continue going positive. And then from 4 to 8, the function is negative. So I come from the negative world and I must hit 8. That's my x-intercept. Right here at 8. And then from 8 forward, the function is positive. Now, of course, I have the asymptote here. So that means that I'm going to cross, intercept and cross, and now go to the positive world, but I will stay very, very, very close to the asymptote. Never go back to negative, never go back to 0, but I'm going to be very close to the value. This is the asymptote, so the function will continue being very, very close to 0. How small? We don't know. We can evaluate the function. We can find f of 9, 10, 11, 12, etc. So we know the values. If you are very curious, you can do that with the graphing calculator. If you don't have a graphing calculator, of course, we can always use Excel. And that's what I did here. I wrote the function f of x equals x minus 8 over x squared minus 16. How does it look like? Let me step here. So it will be cell B3, which is the value of x, minus 8 divided by the cell B3 squared minus 16. Notice the parentheses, so one divided by the other with the parentheses. That's it, so just calculate. Just drag the value. So for this one would be, of course, B4, B5, etc. You punch in the values of x, you find the f of x. Of course, notice that when x equals negative 4, the function is not defined. If I were to use the, it will give me division by 0, which we knew, okay, which is not defined. Likewise here as well in the 4. I put this one big here when x equals 8. That's my x-intercept. Y equals 0. Notice that when x equals 9, we go a little bit up to 0.1, 0.2. As I keep moving up in x, the value keeps going up. However, once I hit 21, give or take, well, actually, once I hit 19, 0.032, now I keep going down again. And then I'm stuck at, I keep going down 0.021. So eventually I will hit almost 0. I mean, but this will be crazy. Okay, there you go. So actually, let me just do 1,000. Wow. 2,000. Let me see if Excel is intelligent. Yes. Notice I make it very, very small, so it will never get to zero, but it's rounding down to zero. I don't know what I'm doing this. Just don't. So anyway, so you keep going like that. So that's how you explore the asymptote, but I'm not going to do it. Okay, so you see, notice it's almost zero, but we never get to zero, the bigger the x. Okay, so there you have it. So as I said, as x goes to infinity, this one will tend to go to almost zero. That would be, this is your function.